In this lesson, we shall continue with the discussion about sets. And just to remind you, a set is a collection of distinct objects. And we said that objects found inside a set are called elements. Now, today we want to look at the different types of sets in mathematics. Let's start with the first one. A finite set is a set which contains a definite or countable number of elements. If you can count the number of elements within a given set, then that set is said to be finite. For example, if I have a set A, which is even numbers less than 10, so this set A contains even numbers less than 10, meaning we can easily count those numbers. The elements inside this set are countable. And in this case, we say A is a finite set. An infinite set is the opposite of a finite set. For it contains an uncountable number of elements. Let me assume, just like in set A, we have here a set of even numbers, B. But this time, I'll just say even numbers. Now, the set of even numbers is unlimited. It contains an uncountable number of elements. We could name as many numbers that are even as possible. So this set here has an uncountable number of elements, and therefore it is said to be an infinite set. An empty set is a set which contains no elements, and it is also known as a null set. Now, if set A is an empty set, then it has no elements. So we could write A, we could denote it as just to write curly brackets without anything, or we could use this symbol. So this symbol here represents an empty set, which is a set which contains no elements. Equal sets are sets which have the same number of, these are sets which have the same elements. Those are what we call equal sets. Sets which have the same elements. For example, if I have a set P which contains elements 1, 2, 3, 4, then I have another set Q which contains elements 3, 2, 4, and 1, then when you look at these elements in both sets, those elements are the same. So these two, P and Q, are said to be equal sets because they have the same elements. So that's what you mean by equal sets. Equal sets are those ones which have the same elements. Equivalent sets are those sets which have the same number of elements. Now, this should not be confused with equal sets. And if I have two sets A with elements maybe A, B, C, and D, then, and I have a set B which has elements E, F, G, and H. These two sets are equivalent. because they have the same number of elements. Set A has 1, 2, 3, 4 elements, and set B has 1, 2, 3, 4 elements. So for two sets to be equivalent, they don't need to have the same number of elements. They don't need to have the same elements. They need to have the same number of elements. If the elements are equal in number, then those two sets are equivalent. And that poses some very interesting fact. We can note it that all equal sets are equivalent, but not all equivalent sets are equal sets. So two sets could be equivalent when they're equal, but doesn't mean all equivalent sets are equal. So that's something important to note. Another thing we can note is that number of elements, cardinal number of a set, refers to the number of elements that set has. For example, set A and B, both of them have 4 elements, so their cardinal number is 4. And that means that all equivalent sets should have the same cardinal number, because for two sets to be equivalent, they have to have the same number of elements. And disjoint sets are those sets that do not have any elements in common. And such sets obviously have no intersection. If two sets are disjoint, then their intersection is 0. For example, if I have set X, which is having elements 1, 4, 5, and maybe 9, and I have Y, which has elements 11, 2, 7, and maybe 10, then X and Y are said to be disjoint sets because they don't have any element in common. So their intersection in that case would be 0. And if I were to indicate them in a Venn diagram, then this would be X, this would be Y. X, Y. They don't meet anywhere, they have no intersection, so they're disjoint. That's what we mean by disjoint sets. And now we have also what we call subsets, and we know that we're saying that a set P is a subset of a set Q if every element of P is also an element of Q. So if we have two sets and every element is in one of the sets is also found in the other sets, then the set will be said to be a subset of the other. For example, if P contains the numbers 0, 2, 4, 6, and 8, and then Q contains the numbers 0, 2, 4, 6, 8, and maybe 10, then P is a subset of Q because every element in P is also in Q. And that brings us to a very interesting fact, which says that every set is a subset of itself, because every element in that set is also found in that set. So every set is a subset of itself. But in summary, a subset, if P is a subset of Q, then the implication is that every member in P is also a member in Q.